Have you ever wondered why Earth does not quietly loosen its grip on the sun, drifting into the endless dark like a fallen leaf lost at sea? In a universe that is almost completely empty, with no invisible strings and no cosmic rails, what persuades the planets to move in graceful circles, day after day, for billions of years? This video promises to reveal a truth that is both simple and astonishing, where motion, gravity, and balance whisper an ancient story of the cosmos. If you have your own theory, leave a comment as if you were sending a message into space itself. And now, let us move forward together to confront the central question that guides this journey. Why do planets not fly straight into the void, but instead continue to orbit the stars that gave them light? What if the planets are not being held at all, and what we call an orbit is simply a kind of endless falling that never quite reaches the ground? Imagine the night sky as a vast, silent ocean, black and bottomless, and each planet as a glowing vessel moving across it with quiet confidence. There are no visible tracks, no celestial rails etched into space, no hands pushing from behind. And yet, night after night, year after year, Earth returns to the same path around the sun with almost ritual devotion. In a universe that is nearly empty, this loyalty feels mysterious. Why does our world not simply drift away into the cold dark beyond the reach of light? Why does it keep circling, as if remembering a promise made long ago? This question matters because it challenges a deep intuition we carry from everyday life. On Earth, motion fades unless something keeps pushing. A rolling ball slows. A thrown stone falls. Stillness feels natural, and movement feels temporary. Space tells a different story. Isaac Newton once hinted at this shift in thinking when he spoke of uncovering laws that apply equally in the heavens and on Earth. Out there, motion does not need constant encouragement. In the near vacuum between worlds, movement persists with a kind of calm honesty. If nothing interferes, an object continues as it is, not because it is guided, but because there is nothing stopping it. To understand orbit, it helps to abandon the idea of being held and replace it with the idea of balance. Picture standing on a high mountain and throwing a stone forward. It travels, curves, and strikes the ground because Earth's surface rises to meet it. Now imagine throwing it faster. The stone travels farther before it falls, faster still, and the ground curves away beneath it. At just the right speed, the stone keeps missing Earth forever. It is always falling, and yet it never lands. That unfinished fall is an orbit. This is not a trick or a metaphor meant only for classrooms. It is the living reality of planets and moons and space stations. Astronauts drifting inside the International Space Station are not floating because gravity has disappeared. They are falling, together with their spacecraft and with Earth itself. Everything shares the same downward pull, the same curved path, and so weight vanishes into harmony. Orbit is not an escape from gravity. It is a partnership with it, an agreement between forward motion and inward pull to keep turning instead of colliding. Johannes Kepler once described the motions of the planets as obeying hidden harmonies, and even now that language feels appropriate. A stable orbit is like a dancer leaning into a partner's hand, not to be restrained, but to spin more beautifully. Too slow, and the dancer collapses inward. Too fast, and the dancer slips away into the crowd. Between those extremes lies a narrow, precious balance. When it is found, the motion can endure for billions of years, longer than mountains rise or oceans form. So if space offers no rails and no resistance, what keeps Earth near the Sunday? The humbling answer is that nothing holds it in place. There is no chain, no hook, no invisible tether. Earth stays because the universe does not require tracks when it has laws. Gravity does not drag the planet along a circular path. It gently and continuously redirects Earth's straight-line motion, bending it just enough to close the curve. If the sun were to vanish in some impossible instant, Earth would not freeze or spiral in confusion. It would fly off in a straight line, tangent to its former orbit, like a pebble released from a sling. That possibility reveals the truth. Orbit is not a cage. It is freedom, subtly curved. Albert Einstein offered a deeper way to feel this idea when he suggested that gravity is not merely a force, but a shaping of space and time themselves. Whether taken literally or as a powerful metaphor, the image transforms the sky. Planets are not pulled by invisible ropes. They follow the natural contours of a cosmic landscape shaped by mass, like marbles rolling along gentle slopes we cannot see. Mass tells space-time how to curve, and space-time tells mass how to move. The sentence is often repeated because it carries a strange meditative clarity, like a mantra spoken in the quiet between stars. This same logic reaches far beyond planets and stars, touching the very limits of what we can know. When we speak of the observable universe, we are not naming all that exists, but all that has had time to reveal itself to us. Light travels at a finite speed, and the universe has a finite age. The result is a horizon made not of walls, but of time. You stand at the center of that sphere, not because you are special in space, but because observation itself is personal. Your view of the cosmos is shaped by what can reach you, just as a planet's path is shaped by its motion and its neighbors. Seen this way, orbit becomes more than a mechanical explanation. It becomes a lesson in relationship. Nothing moves alone. Paths emerge from interaction, from balance, from timing. Earth does not stay with the sun because it is forced to, but because the conditions of motion and gravity align in a quiet agreement. In the same way, our understanding of the universe is not built on absolute stillness or perfect certainty, but on dynamic balance, on questions that curve our thinking rather than end it. The personal lesson I take from this is one of humility and patience. Stability does not come from being held rigidly in place. It comes from moving with the right speed, in the right direction, in conversation with the forces around us. The universe does not cling, it guides. And perhaps that is why it feels so strangely peaceful. Everything is in motion, everything is falling, and yet for long stretches of cosmic time, nothing falls apart. If history teaches us anything, it is that the deepest truths often look counterintuitive at first. Planets do not stay because they are trapped. They stay because they are moving just right. And maybe that is the quiet wisdom hidden in the sky above us. Not that the universe is holding on, but that it knows how to let things move together without losing their way. Have you ever noticed how the word orbit sounds gentle, almost domestic, as if the planets are simply taking an evening walk around their star? And yet the truth is far more dramatic, because everything in orbit is falling, and falling is never gentle. So the real mystery is not why planets move in circles, but why they can fall forever without ever crashing, and why they do not simply drift away into the black like forgotten sparks. Many people picture gravity as a rope, a cosmic leash pulling Earth around the sun the way a hand swings a stone on a string. It is a comforting image, because it suggests control, a tidy circle, a force that holds and guides. But gravity is not a leash, and the sun is not dragging Earth along a track. If anything, Earth is the one trying to leave, like a traveler who would gladly continue straight ahead, while the sun quietly insists on a curve. That is why the first question matters so much, because it exposes a hidden misunderstanding. Is gravity pulling a planet into a circle, like a rope makes a loop, or is the circle a side effect, a compromise, a truce between the planet's desire to move straight and the star's insistence that nothing escapes so easily? And once you feel that tension, the second question becomes inevitable. Is an orbit a natural curved road that objects are forced to follow, as if space itself contains invisible grooves? Or is the curve simply what happens when a straight path is continually corrected, moment by moment, by an attraction that never sleeps? This is where the universe becomes strangely poetic, because it behaves like water finding its level, not by planning, but by obeying. And the obedience looks like choreography only because it has had billions of years to refine itself. I think this is why orbits feel spiritual to so many of us, because they resemble devotion, a repeated return, a promise kept across deep time. But the physics is even more beautiful than the metaphor, because it does not require romance to create it. It requires only two ingredients that sound almost too simple to be true: a pull inward and a sideways motion that refuses to surrender. Imagine you are standing on a frozen lake at night with a small lantern in your hand, and you spin slowly, watching the light trace a circle on the dark ice. The lantern is not tied to the circle, it is tied to your hand, and the circle is simply the shape that appears when something is constantly redirected. Gravity is that hand, patient and silent, and the planet is that lantern, always trying to fly straight, always being turned, always returning. This is why the string picture breaks down in a subtle but important way. A string pulls the stone inward and also forces it to keep turning, because the stone is literally constrained. Gravity does not constrain the planet in that mechanical way. It merely accelerates it inward, and the turning emerges because the planet already had sideways speed. And that sideways speed is the secret origin story most people never hear, because it sounds too ordinary. The planets were born moving. They formed from a spinning disk of gas and dust around the young sun, and in that grand cosmic whirl they inherited momentum, a kind of ancient insistence to keep going. Remove the sun's gravity, and Earth would not pause politely in place. It would shoot off along a straight line, continuing like a thought you cannot unthink. This is the quiet genius behind Newton's old cannon thought experiment, where you imagine firing a cannonball from a mountaintop faster and faster. At low speed, it arcs down and hits the ground. At higher speed, it falls, but the ground curves away beneath it. At the right speed, it keeps falling around Earth, missing the ground forever, becoming a moon made by human hands. We have done this in real life, with satellites, and with the International Space Station, a craft that is not floating above Earth the way a feather floats in air, but falling continuously through near vacuum, circling because its sideways speed keeps carrying it forward as gravity keeps pulling it down. That single image, falling without impact, is the doorway that makes the third question feel almost obvious. If gravity exists, why doesn't Earth fall straight into the sun? Because it is falling, just not in the way our instincts expect. It is falling around the sun the way a skier carves around a mountain, always pulled inward by the slope of gravity, always carried onward by momentum. And the orbit is the shape of that ongoing negotiation. You can feel it in your bones if you picture a marble inside a smooth bowl. Push the marble sideways, and it curves around the center, not because the bowl contains a circular track, but because the inward slope constantly redirects the marble's straight motion. The marble keeps trying to go straight, the bowl keeps turning it, and the result looks like a natural path only because the rule repeats every moment. Now extend that bowl to the sky, and let the slope be gravity itself. In modern language, space and time are not merely a stage where objects perform, but part of the script that shapes the performance. And even if you prefer the older, simpler language of force and pull, the feeling remains the same. Orbit is a continual correction, not a pre-built road. I love a line often attributed to Isaac Newton. Gravity explains the motions of the planets, but it cannot explain who sets the planets in motion, because it hints at something human in the problem, our hunger to know not only how, but why the story began. And then there is Albert Einstein's haunting remark: the most incomprehensible thing about the universe is that it is comprehensible. Because here we are, fragile minds on a small world, able to understand that a planet's endless circling is not magic, but a rule written into reality. And Stephen Hawking's gentle instruction, look up at the stars and not down at your feet. Because the moment you truly understand orbit, you stop seeing the night sky as decoration and start seeing it as a living clockwork of falling worlds. Yet even after all that, the emotional punch does not fade. In fact, for me, it deepens, because the universe is not holding us in place like a jailer. It is balancing us like a dancer holding a partner in a turn, not with chains, but with timing. And timing is everything. Too little sideways speed, and the planet spirals inward, eventually plunging into its star. Too much, and it escapes, becoming a wanderer between suns. So what we call stability is really a narrow sweet spot, a kind of cosmic breath held for a very long time. This is why I think orbits offer a quiet lesson that reaches beyond astronomy. We often demand absolute certainty, a fixed track, a guarantee that we will never fall. But nature rarely grants that kind of safety. Instead, it offers balance, dynamic, and alive, a continual adjustment between pulling inward and moving forward. And perhaps that is why orbit feels like meditation when you really sit with it. Because meditation is not stopping the mind, it is watching the mind return, again and again, guided not by a rigid rail, but by a gentle correction. The mind drifts, the attention returns, the planet tries to fly straight, gravity turns it back. And the beauty is not in never drifting, but in the returning. So if you have ever felt like life is a strange loop of momentum and pull, desires that carry you forward and responsibilities that draw you inward, you are not imagining it. You are living inside the same kind of physics that guides the planets, and I would genuinely love to know what you believe. Is gravity, in your imagination, more like a rope, more like a whisper, or more like a sculptor shaping motion into meaning? Leave your thought in the comments, not as a quick answer, but as a small signal sent into the dark, because sometimes the best part of science is realizing we are all asking the same question together. And now, with that image in your mind, the falling world that never hits, let's go one step deeper into the heart of it. Because the next piece is the one that makes everything click. Why planets do not fly straight into the void, but instead continue to orbit the stars that gave them light. What if Earth had been born with no sideways speed at all? What if, in the first quiet moments of the solar system, our planet simply stood still while the sun began to gather its light? Would we be here to wonder about it now, or would Earth have fallen inward, not as a dramatic plunge, but as a slow surrender, spiraling into a growing furnace until oceans became steam and stone became memory? I want you to picture it like this. Hold a pebble in your palm, then let it go. It does not orbit your hand, it drops. Without a sideways motion, gravity does not create a graceful dance. It creates a straight confession, a fall. And that is the first truth that shocks people when they really feel it. Orbit is not the opposite of falling. Orbit is falling, perfectly timed. A continuous falling that never quite arrives. As Isaac Newton hinted in his famous cannon thought experiment, if you could fire a cannonball fast enough, it would keep falling around Earth instead of hitting the ground. Not because gravity stopped, but because the ground curved away beneath it at the same rate. The universe does this everywhere, silently, patiently, without applause. So where did the sideways speed come from? Where did the planets get that first push that saved them from simply collapsing into their star? The answer is older than Earth and more ordinary than it sounds. It came from the spinning cradle of the solar system itself. Before there were planets, there was a vast, cold cloud of gas and dust, so wide and thin you could pass through it and never notice. Yet it had a faint, stubborn rotation. Maybe a nearby star exploded and nudged it. Maybe passing clouds tugged it. Maybe it was already turning long before our story begins. And then gravity did what gravity always does. It pulled inward. But as the cloud shrank, the rotation sped up, the same way a figure skater spins faster when drawing in their arms. That simple, almost poetic conservation of angular momentum became destiny. A disk formed, a bright spinning platter around a newborn sun, and inside that disk, dust grains met, clung, collided, grew. Every clump inherited the disk's motion, like children inheriting the accent of a homeland they never chose. When people ask why planets orbit instead of drifting away, I often want to answer with a gentler question. What does it mean to drift in a universe where motion never truly disappears? In space, there is almost no air to steal your speed, no friction to calm you down. And here we arrive at the idea that feels like a koan, a riddle you can hold in your mind until it softens. Straight line motion is the natural state because nature does not waste effort. It does not keep pushing when pushing is not needed. As Galileo put it, a body in motion stays in motion unless something interferes. Newton later carved this into what we call the first law, not as a slogan, but as a profound correction to our earthbound intuition, where everything slows because air and ground are always tugging at it. Think of a hockey puck on ice. It glides. It keeps its promise for longer than you expect. Now imagine the ice becoming perfect, the air vanishing, the friction approaching zero. The puck would not need encouragement. It would simply continue. Space is that near-perfect rink, and the planets are not held in place like ornaments on a string. They are moving forward with enormous momentum, while gravity keeps bending their path inward, just enough to make forward motion become a loop. Einstein described gravity not as a hook that grabs, but as the shape of space and time itself. Matter tells space-time how to curve. Space-time tells matter how to move. And in that curved geometry, the straightest possible path can look like an orbit, a straight line, written on a curved canvas. Now return to the haunting version of the question. What if Earth had no sideways speed? Then there is no loop, only collapse. And collapse is not always a crash. It can be a slow spiral, as gravity trades distance for heat and the system searches for a new equilibrium. You would not see blue skies. You would not see seasons. You might not even see a stable planet. You would see an accretion stream, a glowing ring of wreckage, a world being unmade and recycled into the star. In a sense, the sideways speed is the thin line between a habitable surface and a furnace, between a long story and a story that ends in its opening sentence. But there is another layer that feels almost spiritual when you sit with it long enough. We often talk about gravity as if it is the only actor, the tyrant of the cosmos. Yet gravity alone would simply gather everything into one place. It is motion that prevents the universe from becoming a single point. Motion is the counterweight, the breath, the refusal to collapse. Carl Sagan once reminded us that we are made of star stuff, and I think about that here in a different way. Not only are our atoms forged in stars, but our existence depends on a delicate inheritance of motion from an ancient spinning disk. We are, quite literally, the children of rotation. And if you want a mental picture that locks this into your intuition forever, try this. Imagine you are driving at night on a mountain road. Your car wants to go straight, always. The road curves. And if you take the curve too fast, your straight line momentum wins and you fly outward into darkness. If you take it too slow, you may drift inward toward the cliff wall. The perfect speed creates a smooth arc. Orbit is that same negotiation, but written in gravity and vacuum instead of asphalt and guardrails. Too fast and you escape the sun's pull, becoming a wandering comet or an interstellar traveler. Too slow and you fall inward, becoming heat and light inside the star. So when we ask, where did the planets get their initial velocity? We are really asking, where did the universe get its first gentle spin? And the honest answer is that we can trace the mechanism. but the ultimate origin still has mist around it, turbulence in interstellar clouds, ancient collisions, the restless choreography of a galaxy. The cosmos is not a still photograph, it is a moving river, and in rivers, swirls are inevitable. My personal lesson in all of this is unexpectedly human. I used to think stability meant stillness. Now I think stability is motion held in balance. Earth is not safe because it is stationary. It is safe because it is moving at exactly the right speed in exactly the right place. A living world sustained by a kind of celestial momentum. And that makes me wonder about our own lives. How often do we try to stop in order to feel secure, when what we really need is the right direction and the right pace? A forward motion guided by a gentle inward pull, not too tight, not too loose. Richard Feynman once said, "I think it's much more interesting to live, not knowing, than to have answers which might be wrong." And I carry that with me when I look at the sky. Because even when we explain orbit with laws and equations, the feeling remains. A planet suspended between falling and fleeing, between surrender and escape. And the deeper you go, the more the universe sounds less like machinery and more like music. So the next time you look up and imagine Earth sailing around the sun, do not picture a leash. Picture a vow of motion, a straight line desire continually curved into a circle. And in the space between those two truths, our entire history unfolds. And with that in mind, let's go one step deeper. Because the real mystery is not only that planets orbit, it is why that first sideways whisper of velocity existed at all, and how the emptiness of space makes straight the most natural path a world can take. Have you ever wondered what an orbit really is? Not a perfect circle drawn by some invisible compass, but a quiet miracle happening every second above your head. When we say a planet orbits, it sounds calm and orderly, as if the universe built a track and the world simply follows it. But the deeper truth is stranger and more beautiful. An orbit may be a kind of falling that never quite finishes, a perpetual descent that keeps missing the ground by the smallest imaginable margin. That single idea changes everything, because it turns the sky from a static dome into a living motion. It also answers a question most people feel but rarely speak out loud. Why do planets not drift away into the black? And why do they not plunge straight into the star that holds them? The answer is not because gravity is strong. Their prietzas included shaman the videos. It is because gravity is precise, and because motion has a stubborn memory. In everyday life, we think of falling as a failure. A cup slips from your hand and breaks. A stone drops into water and is gone. Falling feels final, a one-way trip. Yet, in space, falling can become a dance, and the ground can be something you never reach. Gravity pulls, but sideways motion carries, and the two together create a path that curves endlessly around a center. This is why the old thought experiment still hits like lightning. Imagine standing on a high mountain with a cannon. Fire a cannonball slowly. It arcs and lands. Fire it faster. It lands farther away. Fire it faster still, and the surface of Earth curves away beneath it at almost the same rate the ball falls. So it keeps dropping, yet never meets the ground, because the ground is always slipping away. What you have made is not magic. It is a satellite, a human-made moon born from a simple idea. The point is not the cannon. The point is the balance. There exists a speed where the sideways going matches the downward falling. Tuite it, and the result is a continuous curve through space. If you remove gravity, the object will not circle anything. It will fly straight as an arrow into the void. If you remove sideways speed, gravity wins immediately and the object drops inward. Orbit is the thin middle thread between these extremes. Not too slow, not too fast. A compromise that lasts for eons. Albert Einstein once put it in a way that feels almost like poetry. Gravity is not a force. It is a consequence of the curvature of space-time. For Memmer, dollars in dollars. In that view, planets are not being yanked around like beads on a string. They are following the curved geometry of the universe itself. The path looks like a circle to us, but deeper down it is a straight line traced across a bent fabric. And that is why the concept of falling forever is not just a metaphor. It is a glimpse into how reality is stitched together. Richard Feynman offered a different kind of reminder. Nature uses only the longest threads to weave her patterns, so that each small piece of her fabric reveals the organization of the entire tapestry. Asa, when you watch a planet orbit, you are seeing one small piece of the tapestry, and it hints at the grand design of motion everywhere. From the moon circling Earth to galaxies circling their common centers of mass, the same logic repeats, again and again. Like a refrain, the cosmos cannot stop singing. So what happens if we keep increasing that sideways speed? Faster and faster, as if we could keep turning the dial. At first, you shift from a short arc to a long arc, from a throw to a near orbit. But beyond a certain threshold, the story changes, because not hitting the ground becomes not coming back. For Manages, there is a speed where the path stops being a closed loop and becomes an open road. Once you reach escape velocity, Earth's gravity can still tug at you, but it cannot pull you back into a bound orbit. You are no longer falling around Earth. You are leaving Earth. This is where a simple example helps the mind. Think of rolling a marble inside a smooth bowl. Roll it gently. It curves around and returns. Roll it harder. It climbs higher on the walls and swings wider. But if the bowl had a low rim and you rolled fast enough, the marble would fly out and never circle the center again. Orbit is the marble that keeps looping inside the bowl. Escape is the marble that clears the rim. And the rim, in space, is set by mass and distance, by how deep the gravitational bowl truly is. What I find most humbling is how indifferent the universe is to our feelings. It does not want planets to stay, and it does not try to make them leave. As Neil deGrasse Tyson says, the universe is under no obligation to make sense to you. I different so, yet it does make a kind of sense, not because it is designed for our comfort, but because the rules are consistent, and consistency creates beauty. A planet remains in orbit not because it is loyal, but because it has the right speed at the right distance, and because there is almost no friction in space to steal that motion away. And that becomes the quiet lesson I take from this idea. Orbit is patience made visible. It is the art of not rushing inward and not fleeing outward. It is a living example of balance, of how two truths can oppose each other and still create harmony. Gravity pulls you toward the center. Momentum carries you forward. And the result is a stable path that can last longer than civilizations, longer than languages, longer than our memory. When you look up tonight, try to feel it rather than only understand it. The moon is not hanging there. It is moving, falling, and missing Earth with exquisite precision. You are not standing still either. You are riding a planet that is also falling around the sun, and the sun is moving through the galaxy, and the galaxy is drifting among other galaxies. Everything is in motion, and yet, here we are, able to breathe, able to ask questions, able to notice the pattern. So let me ask you the hook that matters most. If an orbit is falling forever without hitting the ground, what does that say about the way you handle your own momentum in life? Are you being pulled inward by fear, or flung outward by restlessness? Or have you found the calm middle path where motion becomes meaning? Drop your thought in the comments. A single line from your mind to this vast night sky, and keep watching. Because the next step is where we discover the exact point at which falling around becomes breaking free. I was awed. The speed where the ground never arrives, and the stars begin to feel close enough to reach. What if I told you that a planet does not cling to its star at all? What if it is trying to leave every single second, and the only reason it does not vanish into the black is because the universe keeps gently turning its shoulder, again and again, like a slow dance that never ends? Most of us picture gravity as a kind of invisible rope, a tug that drags the planets around like obedient beads on a string. But the deeper truth is stranger and far more beautiful. Gravity does not need to create an orbit the way an engineer creates a track. It only needs to bend what would otherwise be a straight journey. Richard Feynman captured the heart of it with plain honesty. If something is moving, with nothing touching it, it will go on forever, coasting at a uniform speed in a straight line. One's eyes. That single sentence is a key you can carry in your pocket, because it means every planet is born with a desire to keep going forward, and every orbit is the compromise between that forward stubbornness and the inward pull of gravity. Picture a bowling ball rolling across a perfectly smooth floor. No friction, no bumps, no hands. It does not seek a circle, it seeks a straight line. Now imagine the floor is subtly sloped toward a drain in the center. The ball still tries to roll straight, but the slope keeps stealing a little bit of its path inward, so it curves, not because it wants to curve, but because something keeps leaning it off course. That is what gravity does to a moving world. It does not whisper "go around." It simply whispers "fall toward," and the motion does the rest. This is why the old phrase "orbit is falling forever" is not just poetry. It is a usable mental picture. Feynman says it bluntly in his discussion of the moon. The moon falls, in the sense that it falls away from the straight line it would pursue if there were no forces. And once you really see that, the heavens stop feeling like clockwork and start feeling like motion made sacred by balance. A stone on a string becomes a miniature cosmos in your hand. The stone wants to fly off tangentially, straight into the air. Your hand provides an inward pull, not to speed it up, but to keep turning it. The string does not draw a circle in space. It simply prevents the stone from taking the straight escape it would otherwise take. Gravity plays the role of that inward pull, except the string is not attached, and the hand is not visible, and the dance floor is the fabric of space itself. So let's answer the delicious thought experiment your mind keeps poking at. If gravity were suddenly switched off, what would the planets do? They would not pause. They would not wobble and then forget their orbits. They would simply continue along the direction they were already moving at that instant, flying off on a straight path like sparks flung from a grinding wheel. The Earth would not spiral outward in a graceful farewell. It would shoot away on a tangent, keeping almost exactly its current orbital speed, because inertia does not need permission to persist. In other words, the orbit is not a path carved into space that the planet must obey. It is a moment-by-moment negotiation. Gravity keeps bending. Motion keeps insisting on straightness. And the result is a curve that looks inevitable only because it has been happening for so long. Now here is the part that feels almost meditative to me. An orbit is not a thing, it is a relationship. It is not force alone, and it is not motion alone. It is the balance between the two, like breath and heartbeat, like exhale and inhale. Too little forward speed, and the planet would fall inward, a tragedy written in fire. Too much forward speed, and it would escape, a quiet exile into the interstellar night. Between those extremes lies the steady miracle we call a stable orbit, a world that never arrives, never departs, only turns. You can see this balance in everyday life if you choose the right metaphor. Take a car rounding a bend on a mountain road. Without the inward sideways grip of friction, the car would continue straight and fly outward. With too much grip or too sharp a turn, the tires might lose their smooth motion and the ride becomes violent. In space, the grip is gravity and the bend is the curved path. But the principle is the same. Or picture a marble rolling around the inside of a large bowl. It keeps circling because it is always sliding down the slope while also moving forward. And if you could magically flatten the bowl, the marble would leave the circle instantly and trace a straight line. The bowl does not create the circle. It merely provides the inward bias that turns the straight path into a loop. When people ask whether gravity creates the orbit or only bends a straight line, I think the most honest answer is, gravity creates the conditions and motion creates the shape. Gravity provides the inward acceleration. Motion provides the forward persistence, and the orbit is the story those two tell together. That is why it feels almost spiritual to me that the same simple idea scales from the moon to the galaxies, an elegant economy in the laws of nature. Isaac Newton once said, "I can calculate the motion of heavenly bodies, but not the madness of people." I have delated. I love that line not only because it is witty, but because it hints at something tender. The heavens are not controlled by mood or fear, only by clear principles we can learn. And yet, learning does not make it less mysterious. It makes it more intimate. Johannes Kepler wrote, "The treasures hidden in the heavens are so rich that the human mind shall never be lacking in fresh nourishment." It implies, that is exactly how I feel when I sit with the idea of orbit. Because it is not just math, it is a reminder. We spend our lives trying to hold things still, to pin down certainty, to stop change, to force control. The universe teaches a different lesson. Stability is not stillness. Stability is balance in motion. So, here is the personal takeaway I want to leave you with. If you want something to last, you do not always tighten the rope. Sometimes you find the right speed, the right rhythm, the right distance, and you let the relationship do the holding. A planet stays faithful to its star not by clinging, but by moving. By falling and missing, again and again, until the missing becomes a home. Now, I want to hear your instinct before we go deeper. If gravity vanished for 1 second, do you think Earth would notice as terror or as freedom? And would it matter that orbit was never a track, only a balance? Write your thought in the comments like a small signal sent into the dark, because the most fascinating answers often come from the minds willing to imagine. And in the next part, we follow the thread to the core question that guides everything we have just felt. Why do planets not fly straight into the void, but instead keep orbiting the stars that gave them light? What if the universe is not holding anything at all? What if staying is simply what happens when you do not yet have enough reason, or enough speed to leave? That question sounds almost philosophical, but it points straight into the heart of physics, and into the quiet poetry of motion. Because when people imagine a planet, they often imagine a thing being tugged like a bead on a string, as if gravity were a hand gripping the world, refusing to let it wander. Yet the deeper truth is stranger, and somehow more beautiful. In space, the default is not circling, it is going straight. It is reffing. A planet does not orbit because it is forced to spin in obedience. It orbits because it is already moving forward, and gravity keeps bending that forward motion into a continual turning. John Archibald Wheeler captured this relationship in a sentence that still feels like a spell. Space-time tells matter how to move. Matter tells space-time how to curve. Which again, once you see it that way, the old fear of floating away changes shape. Nothing is floating away because, at every moment, it is still falling inward. Orbit is a fall that never finishes. Picture the classic thought experiment that Isaac Newton imagined. A cannon on a mountaintop, firing a cannonball. Fire it gently, and it lands nearby. Fire it faster, and it lands farther away. Fire it fast enough, and, as the ground curves beneath it, The cannonball keeps missing Earth again and again, and that endless miss becomes a path around the planet. In that story, there is no invisible fence. There is only motion, and the curvature of the route it is allowed to take. So is there a mechanism that prevents objects from going off forever? Yes and no, depending on what you mean by prevents. Adius. There is no cosmic wall. There is no universal glue that says, you must stay here. Instead, there are energy landscapes written into space itself, and your ability to leave depends on whether you can climb out of the gravitational valley you are in. If you have ever tried to hike out of a steep canyon, you understand the feeling. The canyon is not a prison with locked doors, but it demands effort, and the effort is real. Gravity is that canyon, scaled up to planets and stars and galaxies. This is why the phrase escape velocity matters, and why it sounds so dramatic. It is not about escaping a cage. It is about having enough speed that your outward journey will not be turned back into a return. Throw a rock upward and it slows, stops, and falls. Give it more speed and it rises higher before it yields. Give it enough speed and it never yields. That threshold is not opinion or romance. It is a number that falls out of the universe's accounting. How much kinetic energy you have versus how deep the gravitational well is. And once you pass the threshold, there is nothing left to hold you, because you are no longer a resident of that valley. You can feel this in the real world by watching what we have already sent away. Voyager 1 and Voyager 2 did not break through a barrier like ships smashing ice. They simply accumulated enough speed, with careful gravitational slingshots past planets, to keep going outward without being summoned back. Their story is a reminder that leaving is not forbidden. It is expensive. It costs fuel, planning, patience, and the humility to accept that space is vast beyond comfort. And even then, notice what leaving really means. They did not escape the universe. They escaped the sun's local dominion. Beyond that, they still move inside the Milky Way's gravitational embrace, like tiny seeds drifting within a larger storm. This nesting of holds within holds is one of the most important ideas people miss. The moon orbits Earth. Earth orbits the sun orbits the galaxy dances with its neighbors, and clusters of galaxies drift within the influence of still larger structures. At every level, there is always an even wider context. So when someone asks, why don't objects fly away forever? I often answer with another question. Which forever do you mean? Forever from Earth? Forever from the Sunday? Forever from the Milky Way? Or forever from everything? Which is another way of asking whether the universe has an outside at all. And here the second half of your question becomes quietly profound. Maybe there is nothing keeping things in place, only a lack of reason to leave. Because in physics, a reason is often just another name for a force, a push, an energy input, an encounter. Comets are a perfect example. They do not sit politely in permanent loops because they are loyal. They loop because they were born with certain speeds and directions, and they have not yet been perturbed enough to change their story. But then a passing star, or a subtle gravitational nudge, can alter a comet's orbit, and what was once a returning visitor becomes a one-time pilgrim, leaving on a hyperbolic path, never to come back. The universe did not decide to release it. The math simply changed. The same is true for interstellar wanderers like Oumuamua. It entered our neighborhood not because we failed to hold it, but because it was never ours to begin with. It was already on an outbound trajectory from some other system, carrying the memory of a distant birthplace in its velocity. When it passed the sun, gravity bent its path, then let it go again. A brief handshake, not a capture. That is what gravity often is in the wild. Not a chain, but a turning. There is a line from Albert Einstein that people often paraphrase, and even in paraphrase it contains a kind of calm. the idea that gravity is not merely a pulling force, but a reflection of geometry, a curvature of the stage on which motion plays out. When you adopt that view, you stop imagining the cosmos as a battlefield of pushes and tugs, and you begin to see it as a landscape of paths. Some paths are closed and repeat like a lullaby. Some are open and run outward like a confession. And the difference between them can be as simple as speed, direction, and timing. Carl Sagan once said, "We are made of star stuff." Clov, I have treatment. That line is famous because it is true, but also because it reframes belonging. We do not merely live in the universe. We are a local arrangement of it. So, the question of why we don't float away becomes less about being pinned down and more about being in relationship. Relationship to the sun that warms us, to the earth that cradles us, to the galaxy that carries us. In that sense, orbit is not captivity. Orbit is companionship written in motion. My own view, after years of watching how these ideas land in people's minds, is that the most valuable lesson here is emotional as much as scientific. The universe does not need to clamp down on us to keep us in place. It only needs to be consistent. If you keep moving with the right balance, you remain in the dance. If you change your energy, you change your destiny. That is true for planets and probes, and in a softer metaphorical way, it is also true for a human life. Sometimes we are not trapped. We are simply following the momentum we already have. And sometimes freedom is not a door that opens. It is the courage and effort required to reach escape velocity from old patterns. So let me leave you with the question that matters most for what comes next. If orbit is a never-ending fall, and escape is a matter of energy, direction, and timing, then what exactly is holding the planets in their graceful loops right now? And what would it take for them to truly drift away? Drop your own theory in the comments. Do you feel the universe is a keeper or a quiet witness, letting everything go unless it is given a reason to stay? And with that thought hanging in the dark like a small lantern, let's move forward into the next part of the story. Because the moment we understand why planets orbit instead of floating away, we begin to understand what it really means to leave. What if the most familiar motion in the sky is also the most misunderstood? What if the planets are not tracing perfect circles because the universe was never trying to draw perfection in the first place? When we picture an orbit, we imagine a clean ring, like a gold band around a finger, a flawless loop that repeats forever with mechanical certainty. But nature is a storyteller, not a draftsman. And the story it tells is written in ellipses, in slight hesitations, in gentle asymmetries that carry memory. Johannes Kepler discovered this the hard way. After years of trying to force Mars into a circle, he finally let the data speak. And the data confessed something almost poetic. Planets move in ellipses, not circles. Kepler's first law is often taught like a dry sentence in a textbook. Yet it is really a revelation about how the cosmos chooses elegance over idealization. A circle is a special case. An ellipse is the natural outcome when gravity and motion negotiate a living compromise. Here is the heart of it. An orbit becomes a perfect circle only when two things are tuned with uncanny precision. The speed is exactly right, and it is aimed exactly sideways, not inward, not outward. As if you threw a stone so perfectly that it fell forever, yet never got closer or farther. That is the circle, and it is rare, because the universe is not a laboratory with frictionless tables and perfect throws. It is a birthplace filled with collisions, tides, near misses, and the long aftershocks of formation. Think of a figure skater spinning with arms extended. When she pulls her arms in, she spins faster. Not because she wants to, but because the same motion must now fit into a tighter shape. Or think of a child on a swing. A small push at the right moment changes the whole rhythm. In space, those pushes are ancient and subtle. A passing planet, a migrating giant, a resonant tug repeated millions of times. And the result is an ellipse, a path that carries both closeness and distance, like a relationship that breathes in and out. You can feel it in our own year. Earth is not always the same distance from the sun. There is a point where we are slightly nearer, and a point where we are slightly farther. The difference is not dramatic to our senses, but it is real. And it reminds us that an orbit is not a rigid track. It is a dance under a rule. That rule is gravity, but gravity does not command in one voice. It negotiates with the momentum a planet already has. Isaac Newton gave us the clean language for this. And in that language, orbit is what happens when a planet is constantly falling toward the sun yet constantly missing it. Not because it is lucky, but because it is moving sideways fast enough. It is like firing a cannonball from a mountain. Too slow and it lands nearby. Faster and it lands farther. Fast enough and Earth curves away beneath it, so it falls forever. The orbit is born from a fall that never finishes. And this is where the question deepens. What decides whether the path is circular, elliptical, or open? Imagine 3 outcomes, each like a different fate for a traveler. One stays in a steady village loop. One wanders out and returns. One leaves and never comes back. In physics, the difference comes down to energy and speed. Not emotional energy, but the simple bookkeeping of motion and gravity. If a planet's speed at a given distance is exactly the circular speed, the orbit is a circle. If it is less than escape speed but not tuned to perfect circular balance, the orbit is an ellipse. And if it reaches or exceeds escape speed, the orbit opens. An open orbit is a kind of goodbye. It can be a long, graceful curve past the star, never closing. This is how many comets arrive, visitors from the cold outskirts. Some are bound and return after centuries. Others are one-time travelers, bent by the sun's gravity and then released back into the dark. In that sense, an orbit is not just a shape. It is a statement about whether the cosmos has claimed you or merely greeted you briefly. Carl Sagan once wrote, "We are made of star stuff." One, and I always hear in that line a second meaning. Not only are we made from stars, we are also made from their rules. The same gravity that shapes the planets shapes our blood's iron, our bones' calcium, our very sense of up and down. And when you look at an ellipse, you are looking at the handwriting of the same force that made you possible. Now consider the third question, the one that feels almost personal. Can orbits change with time? Yes, and the way they change is a slow music, often too quiet for a single human life to notice. But the solar system is not frozen. It is alive with gentle exchanges of energy and angular momentum. Planets raise tides on each other. Moons raise tides on planets. Stars raise tides on close-in worlds. And those tides are not only ocean waves. They are flexing, stretching, heating, and the gradual turning of orbital energy into warmth. Look at Jupiter's moon Io, for example. It is kneaded by gravitational tugs in a resonant rhythm, and the result is volcanic fire. Or look at how our own moon is slowly drifting away from Earth, a few centimeters each year. That tiny distance, added up over deep time, changes the length of the day and the texture of Earth's ancient sky. Even the planets themselves can migrate. Early in a system's life, giant planets can move inward or outward through interactions with gas and dust. And when giants move, everything else rearranges. A small world can be nudged into a different ellipse, or pushed into the star, or flung into interstellar space like a seed carried by wind. Stephen Hawking once said, "Remember to look up at the stars and not down at your feet." Don't interact. And in this context, looking up means noticing that the sky is not static. It is history in motion. Every orbit you see is a record of what happened during formation. Who collided, who passed too close, who stole energy, who gave it away. And what looks smooth and eternal is often the end result of countless earlier storms. This is why perfect circles are not the default. Perfection requires isolation, and the universe rarely grants isolation. A newborn solar system is a crowded place. Grains of dust become pebbles. Pebbles become rocks. Rocks become worlds. And along the way, they shove, merge, scatter, and resonate. The ellipse is the scar and the signature of that process. And here is the part I find quietly comforting. The universe does not demand we be perfect to be stable. A slightly stretched orbit still holds. A slightly tilted plane still endures. What matters is balance across time, not geometric purity in a single snapshot. When I think about that, I see a lesson that goes beyond astronomy. Our lives are rarely circles either. We have seasons of closeness and seasons of distance, moments when we move quickly and moments when we slow. And yet we can remain bound to what matters, not by rigid perfection, but by a persistent balance we keep renegotiating. So when you ask why planetary orbits are not perfect circles, you are really asking why the universe looks the way it does. Why reality carries texture instead of symmetry. Why history leaves fingerprints even on the paths of worlds. An ellipse is not a flaw. It is a confession that a planet had a past. And if you want a simple image to carry with you tonight, picture the sun not as a king with subjects on fixed tracks, but as a hearth, and the planets as travelers circling that warmth, each with its own pace, its own distance, its own story. Some tightly held, some loosely bound, some only passing through, all of them obeying the same quiet law, yet never in exactly the same way. Now I want to hear your instinct on this. Do you feel the cosmos is more beautiful because it is imperfect? Or more unsettling because nothing is truly fixed forever? Leave your thought in the comments, not as an answer, but as a small lantern for others to find. And as we continue, we will follow that falling motion deeper, until the shapes of orbits begin to feel less like geometry and more like memory. What if Earth sped up just a little tonight? Not enough for anyone to feel it in their bones. Not enough to rattle a cup on a kitchen table, just enough to change the shape of its invisible path around the Sunday. Because that is the secret most people miss. An orbit is not a track in space. It is a negotiation. A calm argument between a planet's forward motion and a star's pull. A relationship that only looks effortless because it has been stable for so long. Isaac Newton once wrote, "I can calculate the motion of heavenly bodies, but not the madness of people." 7. In those few words there is a quiet reminder. The sky obeys rules, and the rules do not care how romantic our assumptions are. If a planet increases its speed, its path begins to widen, like a dancer who takes a faster step and suddenly needs more room on the floor. At first, it does not escape. It simply trades a near circle for an ellipse. Still bound, still loyal to the star, but now it spends part of its year farther away, where sunlight thins, seasons sharpen, and the world feels a little more alone. Slow the planet down instead, and the opposite happens. The orbit tightens, the year shortens, and the planet falls inward in a long, graceful spiral of consequence. Not like a stone dropping straight into a well, more like a leaf caught in a slow whirlpool, circling as it sinks, each loop a little closer than the last. That is why staying is not a single state. It is a range of conditions that can drift toward safety or toward catastrophe. Now here's the question that turns curiosity into awe. Where is the actual border between staying and leaving? 80. People imagine a bright line drawn across space, a gate you pass through and suddenly you are free. But nature rarely uses gates. It uses thresholds, and thresholds can feel like fog until you try to cross them. The threshold has a name: escape velocity. Not a speed limit posted on a cosmic sign, but the minimum speed needed so that gravity can no longer pull you back into a closed orbit. If you reach that speed and you aim correctly, your path is no longer an ellipse that returns. It becomes an open curve that keeps going, a farewell written in mathematics. And here is the part that feels almost poetic. Escape is not about outrunning gravity forever. It is about having enough energy right now that gravity cannot reclaim you later. You do not need to defeat the star. You only need to refuse its invitation to return. Carl Sagan said, "We are a way for the cosmos to know itself." End quote. I think about that line whenever we talk about leaving a solar system, because the first thing a traveler must understand is not distance, it is belonging. A planet belongs because it has the right speed at the right place. A spacecraft belongs until it doesn't, and the difference can be as thin as a small change in velocity, a gentle push at the correct moment, a whisper of propulsion at the edge of night. To make this real in your mind, imagine you are spinning a ball on a string. Spin it faster. The string pulls tighter, and your hand feels the strain. Spin it slower. The ball droops inward, and you can almost sense it wanting to fall. Now cut the string. The ball does not curve in a circle anymore. It flies off in a straight line. That straight line instinct is the universe's default, and gravity is the sculptor that bends it into arcs. Or picture a skateboarder in a circular bowl. As long as they keep enough speed, they carve a loop and rise and fall without stopping. But if they slow down, they cannot reach the same height. They spiral lower, and eventually they settle at the bottom. Speed is not just motion, it is freedom from sinking into the center. When we talk about a body escaping a star entirely, we are talking about crossing a boundary of energy, a point where the star's gravity can no longer close the loop. Near Earth's orbit around the sun, that threshold is high because the sun is massive and the well is deep. Yet notice something subtle. The deeper you are in a gravity well, the harder it is to climb out, and the farther you are, the more the same push can change your destiny. This is why space missions often steal energy from planets, why they fall inward toward the sun and then sling outward, why the solar system is not only a family of worlds, it is also a landscape of energy where clever paths matter more than brute force. Stephen Hawking once warned, "Remember to look up at the stars and not down at your feet." Unquote. Wade, it sounds like a motivational line, but in this context it becomes a technical truth wrapped in tenderness. Look up, because the sky is not random. It is organized by thresholds, by the quiet arithmetic of staying and leaving, and by the fact that everything is always moving. So where is the border between stay and go? When today, in the Prabhas, it is not a fence, it is a balance. If your speed is too low for your distance, you fall inward. If your speed is just right, you remain bound in an orbit. If your speed is high enough, you turn the orbit into a departure. And the most haunting detail is this: the border can be crossed without drama. A world could be nudged by an encounter, a passing star, a gravitational resonance over millions of years, and slowly, almost politely, it could be pushed toward an exit. No explosion, no movie soundtrack, just a gradual change in the geometry of home. My personal takeaway is simple and surprisingly human. Stability is not the absence of change, it is the art of balance. Our lives do not float away for the same reason planets do not. Not because we are chained, but because a few forces hold us in relationship. Momentum and gravity in the sky, habit and meaning in the heart. And yet the border is real. A little more speed, a little less, a single decision at the right time, and a path that once returned becomes a path that never comes back. So, as you listen to this idea, ask yourself the question that the universe keeps asking through every orbit. What is holding you here? And what would it take to let you go? Have you ever looked up at the night sky and wondered whether the galaxies themselves are doing what the planets do, circling, falling, and somehow never quite letting go? Because once you allow that question into your mind, everything changes. A planet around a star is not a polite little dance on a painted track, and a galaxy around another galaxy is not a tidy carousel in the dark. Yet the same deep logic can echo across scales so vast that our language starts to tremble. In the simplest picture, yes, galaxies can orbit one another in a way that feels hauntingly familiar. The Milky Way and Andromeda, for example, are bound together by gravity in the local group. And while their story is not a gentle circle but a slow, inevitable approach, it still begins with the same ingredients that keep Earth loyal to the sun: mass, motion, and time. Imagine throwing a stone across a calm lake. If you toss it softly, it splashes down quickly. If you throw it harder, it travels farther before it falls. Now stretch that idea until the lake becomes space itself, and the stone becomes a moon, a planet, a star, or an entire galaxy. Orbit is what you call a fall that keeps missing. A fall with just enough sideways motion to keep the impact eternally postponed. This is why the old Newtonian intuition still feels like poetry. Newton once wrote, "Gravity explains the motions of the planets, but it cannot explain who sets the planets in motion." ADS. That line endures because it admits something honest. Gravity shapes the path, but motion carries memory. Something in the beginning, an ancient shove, a primordial swirl, sets the rhythm, and then gravity patiently sculpts it into patterns we can recognize. And when we move from planets to galaxies, we don't abandon that logic. We deepen it. A satellite orbits a planet. A planet orbits a star. A star orbits the center of a galaxy. A galaxy drifts within a group. Groups stream toward clusters. Clusters trace the hidden architecture of the cosmic web. It's the same melody played on different instruments. Yet here's where it gets beautifully complicated. Galaxies are not hard marbles. They are vast, fragile ecosystems of stars, gas, dust, and dark matter. And when two galaxies orbit, they don't merely circle like dancers holding hands at arm's length. They reach into each other with tides. They trade material. They raise long, luminous arms. They heat and stir the gas. They can even ignite waves of starbirth, like sparks thrown from a cosmic forge. So the principle is similar, but the outcome is more dramatic. When the Milky Way and Andromeda finally meet, the event will not feel like a clean orbit completing a loop. It will feel like weather in slow motion, like two oceans merging, not because they chose to, but because gravity never forgets how to pull. Now consider the next question: does orbit exist at every level? In spirit, yes. Wherever you have mass and motion, you have the possibility of bound paths. But the word orbit becomes less like a circle and more like a family of possibilities. Some paths are nearly closed and stable. Some are stretched into long ellipses. Some are temporary objects captured for a while, then released. Some are chaotic, influenced by many bodies at once. And some are not orbits at all, but collisions written so slowly that we mistake them for stillness. This is why I love the line often attributed to John Archibald Wheeler, because it feels like a bridge between the human mind and the cosmos. Space-time tells matter how to move. Matter tells space-time how to curve. Thanks, Avajang. Whether you picture gravity as a force or as curvature, the message is the same. Motion follows geometry, and geometry responds to mass. So, if you ask whether the universe is a network of balanced falls, you are not being poetic at the expense of truth. You are being poetic because of it. Picture a tightrope walker. They do not defeat gravity. They collaborate with it. Their balance is not the absence of falling. It is the constant correction of falling. Orbit is cosmic tightrope walking. A moon is always falling toward its planet. A planet is always falling toward its star. A star is always falling through the galaxy's gravitational landscape. Even our galaxy is falling through the gravitational valleys carved by dark matter. The difference is that the sideways motion keeps turning the fall into a curve, and the curve into a path, and the path into a story. For a listener trying to visualize this, I like a simple comparison. Think of a marble rolling inside a smooth bowl. If it has too little speed, it spirals inward and settles. If it has too much, it climbs the rim and escapes. But if it has just the right speed, it circles, rising and dipping, forever in conversation with the bowl's shape. Now, replace the bowl with gravity, and the marble with anything that moves in space. That is orbit. That is the balanced fall you are asking about. Yet we should not romanticize it into perfection. Because the universe is not a clock. It is a living system of exchanges. Energy can be lost to tides, radiation, and friction-like processes in gas. Orbits can decay. Moons can drift outward. Stars can migrate. Galaxies can merge. Even stability is often just a long-lived phase in a larger transformation. And that brings me to the real lesson I take from this idea. It's not merely that gravity binds everything. It's that existence itself seems to be a negotiation between surrender and momentum, between falling inward and reaching outward, between being held and becoming free. Sometimes I think we learn the wrong emotional message from space. We look at orbits and imagine control, but what we are really seeing is relationship. A planet does not cling to its star out of fear. It continues because the conditions are right: speed, distance, mass, time. In human terms, it is not a prison. It is a harmony. Carl Sagan famously said, "We are a way for the cosmos to know itself." In every way. When I connect that thought to the image of endless falling, I feel something surprisingly gentle. If the cosmos is knowing itself through us, then perhaps our own lives are also a kind of orbit. Not a perfect circle, not a rigid track, but a path shaped by forces we didn't choose and motions we did. And the practical takeaway is quietly powerful. If you want something to endure, you don't only need a pulling force. You also need direction. You need momentum with meaning. Gravity without motion becomes collapse. Motion without gravity becomes drift. But together, they become a world, a sky, a home. So yes, galaxies can orbit each other by a similar principle. Yes, orbit exists in some form across many levels of structure. And yes, you can think of the universe as an intricate web of balanced falls. But the deeper truth is this. What looks like staying is often a kind of movement. What looks like falling is often a kind of flight. And what looks like emptiness is often full of invisible relationships shaping everything you see. If that idea lands somewhere inside you, hold on to it as we go further. Because the next step is even more unsettling and even more beautiful. If everything is always falling, what exactly are we falling through? And what does that say about the true shape of reality itself? Have you ever noticed how the cosmos can look so calm? How the moon hangs there like a lantern that forgot to fall? How planets keep their appointments with the stars, as if someone wrote the schedule long ago and never changed it? And yet the honest truth is almost unsettling. Nothing up there is resting. 5 to 25. Everything is moving. Everything is falling. Everything is perpetually on the verge of becoming something else. When I hear the question, are we living in a temporary but stable state? I think of a smooth river at night. From the bank it looks still, but place your hand in it and you feel the relentless push of water that never pauses. Stability in the universe often isn't the absence of motion. It is motion arranged into a pattern so consistent that our minds mistake it for permanence. This is the first emotional trick the sky plays on us. It offers peace as a visual experience while hiding dynamism as a physical fact. A planet in orbit is not a stone on a shelf. It is more like a dancer who never stops spinning, because the moment she stops, she collapses. The order we admire might not come from a holding force at all. It may come from the exquisite coincidence of falling and missing. That idea sounds poetic, but it is also brutally practical. You can picture it with something as humble as a thrown ball. Toss a ball forward and gravity pulls it down. Throw it faster, and it travels farther before it hits the ground. Now extend the thought until the ground curves away beneath it at the same rate the ball falls. In that case, it keeps falling forever and never lands. That is an orbit in its simplest clothing, a perpetual fall that never reaches the floor because the floor keeps bending away. If that feels too abstract, bring it closer. Think of the International Space Station. Astronauts float not because gravity disappears. Gravity is still very much there. They float because they and their spacecraft are falling together around Earth. Their down is constantly changing direction, and the sensation of weight is replaced by a shared, continuous free fall. It is one of the most profound lessons spaceflight has ever taught us. What looks like stillness is often motion in perfect agreement. So when we ask whether cosmic order comes from a force that holds, we are really asking what kind of order we mean. In everyday life, a holding force is the hand that grips the cup, the nail that pins the picture, the rope that keeps the boat from drifting. But gravity does not hold like a hand. Gravity shapes trajectories. It sculpts the path that motion will take. It does not need to clamp you in place to keep you near. It only needs to bend your straight line urge into a curve. This is why the second question matters so much. Is the secret the force or the speed? The most accurate answer is that it is the relationship between them. A negotiation, not a command. If a planet moved too slowly for the gravity of its star, it would spiral inward. If it moved too fast, it would drift outward and escape, carrying its oceans and dawns into interstellar night. Between those fates lies a narrow corridor where the numbers harmonize, not because the universe is sentimental, but because physics is consistent. And here is where the universe becomes strangely meditative, because that corridor is not only an astronomical concept, it is a metaphor for how stability works in many parts of existence. A bicycle stays upright only while it moves. Stop, and it tips. A violin string makes music only while it vibrates. Silence is not the stable state, it is simply the absence of the pattern. Even your heartbeat is a controlled oscillation rather than a static calm. Life itself is a kind of organized motion that looks steady because it repeats. This is why the third question cuts so deep. If everything is falling, why does the universe look peaceful? It looks peaceful for the same reason a well-shot film scene looks effortless. Because the movement is coherent. Chaos is loud to the eye. Order is quiet. A meteor entering the atmosphere is drama because it is energy being dissipated violently. But a planet's orbit is quiet because it is energy being conserved elegantly. The universe is not calm because nothing happens. It is calm because so much happens in patterns that do not break. There is a line often attributed to J.B.S. Haldane that I've always found useful here. The universe is not only stranger than we imagine, it is stranger than we can imagine. That strangeness is not always monstrous. Sometimes it is simply subtle. A stable orbit is subtle. It is falling disguised as staying. It is change disguised as continuity. Carl Sagan also offered a reminder that grounds the poetry in reality. We are made of star stuff. Thanks for watching. If you take that seriously, then the calm sky is not a distant theater. It is your own ancestry moving above you. The atoms in your bones have ridden cosmic currents, endured stellar furnaces, and traveled through gravitational architectures older than anything we call history. And the same physics that keeps Saturn in its path also arranges the tides on your shoreline and the blood in your veins. Even Neil deGrasse Tyson has a blunt phrase that, whether you love it or hate it, snaps us awake. The universe is under no obligation to make sense to you. I breeded it. But here is the quiet surprise. Sometimes it does make sense. Not because it is trying to comfort us, but because it is faithful to its own rules. And when we learn those rules, the peace we see in the sky becomes something we can understand rather than merely admire. My personal view is that this is where the real lesson lives. We keep searching for something that holds because we fear drifting. We want the cosmos to be a place with anchors, but the cosmos is, in many ways, a place of choreography. It does not promise you a fixed point. It offers you a pattern you can learn. And once you see that, stability stops being a guarantee and becomes a practice. A balance achieved moment by moment, speed meeting pull, motion meeting curvature. So yes, I think we are living in a temporary but stable state. Temporary because nothing lasts forever. Not stars, not orbits, not even galaxies. Stable because the timescales are so vast that the pattern outlives generations and civilizations and the stories we tell to feel permanent. The peace of the universe is not the peace of still water. It is the peace of a river that knows where it is going. And the most valuable takeaway, at least for me, is that falling is not always failure. Sometimes falling is simply what motion looks like under gravity. Sometimes falling is how you stay close to what matters. A planet falls and becomes faithful to its star. A moon falls and becomes a clock for the tides. And perhaps we, too, fall through time in a way that can still be meaningful if we learn the rhythm rather than resist it. So let me leave you with a question that I genuinely want you to answer in the comments. Do you think the universe is held together by something like a grip, or held together by something like a dance? Because the moment you choose one image over the other, you start to see the night sky differently, and you start to see your own life differently too.